All right. Let's let that load up there. All right. So graph 3x plus 2y equals 10. So this is in what's called standard form, ax plus by equals c. If both numbers go into the 10, you typically use the intercept approach,
Okay.
which is to find the x-intercept and the y-intercept and connect them. If it doesn't, which is the case here, because well, 2 goes into 10, excuse me, 3 doesn't, I would generally tell you to solve for y. Now,
Okay.
do you remember what you guys were doing in class at all? Do you remember?
Oh, we just solve for the x and y intercepts by plugging 0 in for both.
Right. So you can see though, if you set x equals 0, that's fine. 2y equals 10, and then
Yeah, so y equals 5.
and that's fine. Okay, 0, 5, boom, we got it. Problem is the other one. That's where you got to kind of look ahead here. If y equals 0, you've got 3x equals 10, x is 10 over 3. That doesn't graph very nicely. Like you got to kind of like be like, where is it? So if your teacher's a real stickler for being really good at graphing, I would not recommend this approach.
Okay.
So if you do solve it for y, you end up getting minus 3 halves x plus 5, and you can get better points. So you can go down 3, right 2, down 3, right 2. And you can see that that point that we have is on the line, but you get better points overall.
Okay.
So that's kind of like the way you'd want to do it, especially on like standardized testing. You'd want to kind of look ahead to see what actually works here. Number 2, already in the right format, mx plus b.
Yep.
So you start at the b value of 1,
Yep.
slope of negative 2, down 2, right 1. They're kind of easing you in here. Now, did your teacher say how many points they wanted you to graph?
No.
So the answer is that you only need 2 points for a line. There's only one line that can go through 2 points as long as they're unique, but they usually want more. So you
Okay.
gotta, that's why I ask. Sometimes they're sticklers for, okay, it's gotta be this many. I had a teacher who actually would get a ruler out and they would like graph down here to see if you got the point that they wanted down way down the page. So it just depends how particular they are on this.
Okay.
Any questions on for move to 3?
Nope.
All right. So I guess maybe your guys are starting to talk about functions a little bit here. Functions really are the same as y equals. You can really treat this f of x as really a y, but the same y-intercept. Okay, sorry. So this is actually something different here. It says complete the table to show output values for a linear function g of x that has a greater rate of change but the same y-intercept as f of x. What is the y-intercept of f of x?
9.
9. Okay. And what is the slope of f of x?
7.
So a greater rate of change means a greater slope.
So it has to be greater than anything greater than 7.
Yeah, and you actually do need to write. Well, you don't have to, but I would recommend doing that. So your new function, let's go like 10x plus 9.
Okay.
So the rate of change is what it increases by every time. So 9 goes to 19. You also get that by putting 1 in for x. G of 1 is 10 times 1 plus 9, which is 19. But the shortcut is to know that the rate of change is what allows you to go up by the same amount each time.
Okay.
I think that's it. Move on to 3 now. I'm sorry,
4.
4. 4.
Yeah.
Yeah, 4. Okay, grab that here. Okay, number 4, Austin is leaving his home and traveling to Nashville, Tennessee. The number of hours since he started driving is represented by X, and Y represents the distance Austin is from Nashville. So what it's showing here is he's 600 miles away, and he's getting closer and closer and closer as he drives. The y-intercept is the vertical axis here, and you want to actually give that y-intercept as an ordered pair. So 0, 600. Then it says, what is the meaning in this context of this situation? That's like interpret. That means to write a sentence. So the teacher's looking for some words that say Austin is blank miles from blank.
Okay.
So in this case, he's 600 miles from Nashville. Like you could say he started out at his house, but we don't actually know that. We just know that he's 600 miles away from Nashville. All right, so part B asks for the slope. The slope is rise over run. You want to pick points that kind of hit the graph perfectly on the grid. So the first one I see that might be perfect is kind of here. Do you agree or disagree? I mean, I think you've got it on your paper there. Is that kind of okay?
Yep.
All right, so the slope here, the rise isn't really a rise. You're actually going down 150 miles. And then your run is 2.5. I think you said you're allowed to use a calculator. I'm going to calculate that for us, please.
Yep. Okay. 60. He's going 60 miles an hour.
Negative 60. So you got to be careful here. So it's the units of y over the units of x.
Yeah.
So it is miles per hour, but you want to be careful here. You want to because then what does the negative mean in this context?
He's getting closer to
Yeah, so
Nashville.
you want to say so they're looking for something. Actually, let me type it here. For every 1 hour that Austin drives, he is getting 60 miles closer to Nashville. That's kind of the college answer, you know, the got everything in it. If you say minus 60 miles per hour, you may or may not get credit. So you want to be a little bit more specific in context. Like when you're on the plane, they tell you, you know, we're going to land in 30 minutes. They don't tell you we're decelerating at a rate of, you know, minus 50, you know, kilometers per hour.
Okay.
What is the equation of alignment and slope intercept form? So that's your y equals mx plus b.
Y equals negative 60x plus 600.
Yeah. Now that only works because they're saying x and y. Sometimes they'll switch these variables to like t and then the distance or something else. So sometimes you write this equation and then you switch the letters to the ones that they want.
Okay.
Any questions on that before we move on to next one here?
Nope.
Great. Oh, I'm sorry. Part D. Matthew, there's part D. We can't go into the next one. All right. So this is in context, this means when does y equal 0? When does it hit the x-axis? So you have to set your equation equal to 0 and solve for x.
Negative, it would be 10. 10 hours.
10 what? Yeah, 10 hours. What's the longest car ride you've ever been on?
3 days.
3 days. That's brutal. It's at first you're like, oh yeah, road trip, it'll be fun. And then you get in the car, you're stuck.
Yeah.
Over and over again. All right. Find the equation of the line that goes through 4,9 and 3,2. So did you do some problems like this in class?
Yeah.
All
So
right, so
it's
I want, so we're gonna,
x2 minus x1 over, or y2 minus y1 over x2 minus x1. Yeah.
yeah, so go ahead and find the slope for me, please.
2 minus 9, so we have -7 over -1. The slope is 7.
Good. So notice it doesn't specify what type of equation.
Yeah.
There's three forms, right? There's y equals mx plus b. Usually they want this. The better one though is point slope form here. Did you guys talk about that in class?
No.
Okay, so that one is out. All right, so you write the equation with the slope in it. Then you pick the ordered pair you like best. I like the second one better. So 2 equals 7 times 3 plus b. Solve for b.
Equals -19. Then y equals
Yeah, you have,
7x minus 19.
and if you want to check to make sure that's perfect, you go back and you try the other point. Does 9 equal 7 times 4 minus 19? And yes, it does.
Okay.
All right. So for number 6, do you have the answers, by the way, for these or not?
No.
Okay. The reason I ask is because there's two possibilities here. Usually we think of these as inputs and outputs, right? Like X is the input, Y is the output. And the question here is what is the input? And typically in a catering situation, the input is the number of people and the output is the cost. Okay, so you have to know this in advance. Like you have to know what is X, what is Y, because in this case, your input is N, your output is dollars. So can you give me the two ordered pairs in this scenario?
10 people.
Yeah, give me the first ordered pair here.
So 110, 175, 20. So 110.
So
Oh, wait, no.
yeah,
10, 100.
yeah, and this is where I'm you got to take a little leap of faith with me that this is how she wants it. Probably does. You might be wondering, well, why doesn't the money come first? Typically when you go into a situation, they ask you how many people are attending, then you get the cost.
Okay.
All right, so will you determine the slope for us, please, on this one?
75 over 15. That's 5. The slope is 5.
Yes. Okay. What does that mean in context? Like, what does 5 represent?
Um,
And think of it as the units of Y, units of X.
so for every person, each is $5.
Yeah, for each extra person in the party, it's going to cost you another $5. Good. Okay, now they want an equation, so we'll go Y equals mx plus b. Go ahead and calculate that for us, please.
Y equals 5x plus 50.
All right. Did you use the first point or the second?
First.
So let's check it with the second. Is 5 times 25 plus 50 equal to 175? Yes, it is. All right, so let me see here. Number 6. Okay, so we're up to 7 on the back. Is that right?
Yes.
All right. Do you have anything else that you'll want to do tonight?
No.
All right. Probably will not take us the whole time to go through this, so just keep that in mind. All right. What are the instructions here? Number Y is 2 less than and 4 times the number. Is there
Oh, it's
something?
just, it's select. Like you circle the correct statement.
Okay, yeah. All right. So the way to do this, I think that will be more intuitive to you is to actually write the equation of this line, which means to first calculate the slope. and then use the y equals mx plus b, and then we can answer this.
Okay.
So go ahead and give me that slope when you've got it.
7 minus 1. So -1/2.
Yeah. All right. So now for function 2, because this is what it's asking about down here. It's like negative rate of change, negative rate of change. Does function 1 have a negative rate of change?
Yes.
It does. Function 2, let's talk about why it does not. It says y equals 2 less than 4 times the number. So you always go with the 4 times first, then subtract 2. Does this have a positive or negative slope?
Positive.
Slope is always the number in front of x. Yeah. Okay, now I finally see what they're doing here. Boy, this took a while to figure out. So function 1 has a negative rate of change. Rate of change means slope.
Okay.
All right, let's look at 8, and let me do this a little bit differently. Let's look at just the table, and you want to calculate the slope. So change in y over the change in x, and you can use the
2
formula if you
over
want.
4, so 1/2.
Yes. So 4 minus 2 over 8 minus 4, it is 1/2. So is this positive or negative?
Positive.
Yeah. Now for the graph, there's no scaling on it, which doesn't really matter, but I mean, it's you'd get marked off if you don't do that. What's the rise over the run here? How much up, how much to the right?
Up 2, right 2, or up 1, right 2.
Yes. So notice these are the same.
Yes.
So I think that is the answer they're looking for, which is that they have the same rate of change. All right, number 9. All right, so function 1, function 2. So let's look at function 2. What is the slope of function 2?
-5.
-5. And that means it's going down, it's decreasing. Function 1, as a candle burns, it is decreasing by 0.5. I assume there's a decimal there, inch every hour. What is the slope of 1?
-0.5.
Perfect. Yeah. So you have to interpret that decreasing means the negative. And so they're both going down. Which is going down by more?
Function 2.
Function 2. So the one with a slower rate of change is actually the one that's going down by less, which is function 1. It's a little weird because they're negative, but the one that's more negative is going faster, going down faster. Is that okay?
Yeah.
All right. All right, so we've actually kind of done one like 10. So why don't I ask you to try solving this here on your own? Like you to calculate the slope of each, or give me the equation if you need to, but
Okay, so the slope of 1 is up 3 and over 2, so it's 3 over 3/2.
so up, so are you going 1, 2, yeah, sorry, I just double checking. 3/2, good.
And 2 so then for number 2 is y equals 15x plus 10.
Yes. So the unit per hour, that's always going to be your rate.
Yep.
If you something per something, that's your rate. Very good. So what's the answer? Is it
It's function 2.
Yes, you got it. This seems like stuff you've probably seen before, meaning like earlier in the course. Not sure though. All right. Let me grab number 11. All right, so we got an equation first. So the slope of the equation is 8, y equals 8x plus 15. What's the slope of the equation down there? Think of days as x, height as y.
So 5/1.
Yeah. You always just write it as 5. So which would be the correct answer? Oh, there's 3 choices this time.
The second one.
Plant 2 is growing. Yeah, so they switched the order there. Yeah, that one's correct. Seems like weeds are growing very fast right now. All right. Number 12. All right, so the slope of function 1 is -3. What's the rise over the run here in function 2? What does that become?
Up 1, 2, 3, 4, 5, 6 over 2. So then
6
3.
over 2, so 3. All right, so function 1 has a positive rate, or function 2 has a positive rate?
Function 2.
Yeah. Good. All right. So number 13, kind of a standardized prep question that you might see. What is the slope of the line represented by 1/8 x plus 3y equals 3? So to do this, you probably want to solve for y.
Okay.
Let me know if you need some help on that. This feels like something you probably have seen before, so give that a shot.
I got B.
That is correct. All right. So is that really everything you've got for homework tonight?
Yep.
Well, that's great. I mean, you're all done with that. We've got some time left. Up to you if we use it or not. Is there anything upcoming that you know about, or maybe you're
No.
just exhausted from all the travel?
Yeah.
I can tell. Um, well, I mean, it's up to you. You're the customer. I'm happy to stop here. It's totally up to you. What would be best for you?
I mean, if you can like teach something
Sure.
something that you think would come after this.
Sure. I mean, just to be fair to you though, like I don't want to go crazy here with stuff if you're tired. So maybe let's do another 13 minutes. Does that sound fair? Or, if you
Yeah.
feel like you can do the whole time. Very good. Okay. So you're clearly doing this thing with functions. The next type of functions that you see are kind of growth and decay functions
Okay.
that are exponential. That's kind of where this tends to move in this course. Okay. So let's look at something like this. Let's say f of x equals 2 to the power of x. Okay. And let's put some values in for x. Let's say x is 0. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. Do you see that the number on the right is increasing at an increasing rate? It's going up. It's doubling basically.
Yep.
So if we put 3 in, we would get 8. And it actually goes the other direction. If you put -1 in, that's 1/2. Put -2 in, that's 1/4. So depending on how you're going, you can either see this as I'm multiplying by 2, multiplying by 2, multiplying by 2, and so on. Now, when you graph this, 0, 1, 1, 2, 2, 4, -1, 1/2, you get a graph that looks like this.
Okay.
And this grows pretty rapidly, okay? But
Okay.
that's kind of an extreme example. They don't have to grow that quickly here, okay? And so let's look at something else that might grow. Let's look at another growth function, okay? So let's say you had a population that started out with 2,000, and we know that it grows at a rate of 5% per year, okay? So in year 0, when t equals 0, what is the population in this one?
0.
Well, t is 0, so 1.05 to the 0 is
Oh, 1.05.
1. This becomes 1.
Yeah. So then 2000.
2,000. Now in year 1, it grows by 5%. Now you probably already know that 5% of this is 100. But if you put this into the calculator, 2,000 times 1.05 to the power of 1. Do you have a calculator handy?
No, but you would get 2100, right?
2,100, right? And so we can do this for even for year 2, because we can actually find some of these values. It ends up being 10% of this is 210, and half of that is 105. So this becomes 22,005. Okay.
Okay.
So there are growth functions that seem to increase with time. All right. So let me give you another example. Let me give you a table here. And let's see if you can tell me what's happening here. So let's go t, p of t, and well, you don't have a calculator, do you? So I can't make this too big. Let's say it's time 0, it's 5, and then at time 1, it's 15, and then at time 2, it's 45. At time 3, it's 135.
Okay.
What do you see here? What are you going up by each time?
3s.
Multiplying
Like
by
multiply
3.
by 3. Yeah.
Yeah. So that's the key difference between an exponential and a linear, is that instead of adding the same amount each time, you're multiplying by the same amount each time.
Okay.
Okay. So what happens is they basically want you to decide, is the function linear or exponential. So let me quickly look for a couple of those problems here. This is only a guess. This is like Matthew hoping that this is what you guys are going to see. Let me grab one that's not super difficult to start with. All right. All right. So when you're looking at this table here, you want to decide if you are adding the same amount each time, or subtracting the same amount, or if it's a multiplying by the same amount each time. So
Okay.
is this linear or is this exponential?
Linear.
What is the slope then?
2/1.
So adding 2, right?
Mhm.
Good. Okay. So how about this one? Is this linear or exponential?
Exponential.
Yeah, because you're going up by 2 each time. And it has to be the same everywhere. So let me give you some ones that are a little bit more challenging here. Take a look at this one. What do you think? Linear or exponential?
Linear.
What's the slope of this one? What are you going?
0.
Yeah, so this one's just constant. Okay. All right, so let's go back to this idea of growth and decay. All right. So we've looked a little bit at growth. So let's now talk about decay. Decay means that it goes down over time. So sometimes we see something like this, like we have a population of, say, 10,000 people, and we know that it's going down by 1% each year. All right. So this function here is decay, and it has to do with the number in here. It has nothing to do with the number in front. It only has to do with the number in parentheses. If that number is between 0, and this is called A, if that number is between 0 and 1, it's decay. It's growth if that number is greater than 1. All right. So again, we could make a quick table here, T and P of T. When T is 0, it's 10,000. And when it's 1, it's 99% of this. So 1% of this, 10% is 1,000, so 1% is 100, so it's 9,900. And we could do the same thing for T. So these growth functions and decay functions, they have sort of two distinct shapes. It's either growing or it's decaying, like that. Any questions on what I've done so far?
No.
Okay. All right, let me take a look at some word problems here. All right, so let's look at some growth problems and decide if they are growth or I'm sorry, linear or exponential.
Okay.
All right, so take a look at this one. What do you think here? Is this growth or decay? I'm
Growth.
sorry. Sorry. Is it, keep misspeaking. Is it linear or exponential?
Linear.
It's linear. Now let's go a bit further. Is it growth or decay? Basically, you can use those words for linear if it's growing or decaying, getting bigger, getting smaller. What do you
Growth.
say? Yes. Okay. All right. How about this one here? Is this linear or exponential?
Exponential.
So there's a key word here, tripled. Okay, so unless it says it's going up by the same amount each year or each time period, then it's some sort of exponential, because tripling means a multiplier. You're multiplying by 3, you're multiplying by 4, and so on here. All right. All right, so just looking for some more problem sets. Sometimes it's hard to do this on the fly to find anything good. Give me just another minute here to see if I can find anything good for us to work on. Nope. All right. Everything is taking so long to load. All right, here we go. Let's look at a new problem here. All right, the trunk diameter D in inches of an oak tree that is T years old can be modeled by the equation D equals T plus 8 divided by 2. according to the model, for every increase in 1 year of age, by how many inches will the diameter of the oak tree increase? All right, so is this linear or exponential?
Exponential.
What makes you say that? What tells you that it's exponential about the way it's written?
The slope.
So this one has a slope. You're right. The slope here is what? What is the slope of this one?
Whatever it is, plus 8.
Okay, so you're dividing both of these by 8. So your d is 1/2 t plus 4. So what is the slope of this one?
Mm,
What's the number in front of x, or what number in front of the variable?
1.
It's 1. 1/2. 1/2.
Okay.
All right. So that means that it's going up by 1/2 every year, and so on. Okay. Let's take a look at new problem here. All right, so let's say I gave you a list of ordered pairs like this, okay, and we wanted to make a quick sketch of what this graph looked like, okay, and that's like whenever you get a data set in real life, that's kind of the first thing you do. You go and graph it: -1, 5, 0, 0, 1, negative 1, -1, 2, 0, and 3, 5. All right, so what does this look like to you?
Parabola.
So is this linear?
No.
Is it exponential?
No.
No. So it has to be the same, right? Like if you want it to be exponential, it's got to have the same multiplier each time. If it's got to be linear, it's the same growth or decay each time. But this one is neither. So sometimes you get problems where they're neither are correct.
Okay.
All right. I can just tell you're fading here. Would you like me to give you any more problems like the ones from your homework to work on?
Mm,
I mean, I'm okay to stop early, but it's up to you. We can
give
definitely do
us
some
a
more.
couple more.
Okay. All right. So let me give you a function here. Let's say v of t equals 900 minus 60t. Go ahead and calculate v of 2 for me, please.
780.
Okay. And now go ahead and calculate v of 7 for me, please.
$580.
Close. So 7 times 60 is 420. 900 minus 420 is 480. Okay, can you tell me what these are as ordered pairs?
2, 780.
The other one is 7, 480.
480.
I want you to confirm that these produce the slope of minus 60. How would you do that?
480 minus 780 over 7 minus 2.
Now, does it matter? Like if let's just say I did it this way. I said 780 minus 480 over 2 minus 7. Does that give you a different result?
No.
No, it does not. And so the order doesn't matter as long as you're consistent, meaning like if this is x1 and y1, then the other one is x2 and y2. You just can't mix them in between.
Okay.
And these of course do both give you that number right there. All right.
Okay.
So let's just say for some that this is some scenario where this represents the value of a car after t months. Okay. So when is the value of the car 0? When is v of t equal to 0? Let me go back up and grab the function in case you need that.
So you plug
900.
in 0 for v of t.
Yes. And you solve for t.
Yeah. Zero, 900 minus 15.
What did you come up with?
150 months.
Yeah. Now, from what you know about cars, I know 900 isn't very, I don't even know if you can get a car for $900 right now, but does that even sound reasonable to you that a car could go to 0 value?
No.
No, typically doesn't. Okay. So let's look at another situation here. All right, so you have saved $1,000, okay? And you need to choose an option, okay? So there's bank one on the left. They'll give you $100 at the end of each year. Okay, and the one on the right will give you 6% annual interest. All right, so I'd like you to give me the equation for the one on the left. What's the I don't know, let's say the value as a function of time. What would that be for this one? What are you starting with?
100 y plus
T
1000.
100t plus 1000. So we're using t as the input here.
Okay.
T for time. T is in years. Now on the
Yeah.
right here, it's 1000 times 1.06 t.
Yep.
Okay, because this we'll talk about this maybe at some point, but which do you think is better after 1 year? Like, what do you think? Like, how far apart do you think they are
Oh,
after
after
one?
1 year?
Yeah, like
Get
let's come.
TFC bank.
So this is 1100, and this is 1060. What do you think the value? What do you think happens after 2 years?
Wells Fargo might. I think TFC might.
So you're up to
go
1200, right?
lower.
And then V of 2 is equal to 1060 times 1.06. So another 6% of that. I'm going to grab a calculator just so we can do this a little faster here. So this ends up being 1123.60. Now, what's the difference in dollars between these in 1 year? What do you see there? $40.
$40.
All right. How about in year 2?
67.
So it actually got bigger.
$77. 60. No.
Yeah, $66.40. This is bad, right?
Yeah.
This is not good. Do you think that this will ever catch up?
Yes.
Yeah, it should, because growth functions do end up doing that. So let's go actually look at that. Let me clear out what I had here. So the scenario is y equals 100x plus 1000. Okay, and my axes are very bad here. So let me make these better. So let's go. Let's say that what's your guess here? When do you think they'll finally intersect? Like if you just had to make a guess, do you think it's like 10 years, 50 years, 100 years? What do you think?
5 years.
5 years. Okay. All right, so all I'm doing here is just setting my domain so that it doesn't graph negatives. There's no reason to do that. So I'm gonna go over to the wrench. Let's go out 50. I'm not really sure. We know that it's 1,000, so we ought to at least go up maybe 10,000. So look at that. They do intersect. But notice that's, and what we were kind of seeing initially, the distance between them actually got like further apart before it got closer. But once they hit, what do you notice about the distance between them? What's happening here?
It grows by a lot more.
Yeah. So if you have time in your favor, and being young, you have time in your favor, even a lower rate of return will over time give you more money in this type of example. All right, let's go ahead and stop here.